I pinned Daniel Wicks. I don't know if he can join or not. We probably can get started. So I'll first do a quick recap of what we had discussed last time. I think in last meeting, we talked about should we have this max staleness config, right? I think the consensus, yes, we should, because it can enable a big, broad use cases where some staleness is allowed, like for example, some ETL type of workload. There's a lot of platforms have support those kind of material view use case. So we said that we should have those kind of config to support those MOV use cases. Second is where should it be defined. Should it be defined the view metadata or define the storage table metadata? So the consensus we should define in the view metadata, because I think Benny had a good point that when we create this material view with this config, the storage table may not be even created because there's no refresh happen. So I think that good argument that config should define the view metadata. I see in the PR discussion, Yang was asking, should that be some config property or should it be a metadata? I don't know in the view, I don't know if there's any config property. So maybe it should be just metadata in the view definition. Yeah, so those are kind of the two things we kind of have some consensus last week. The one open question we have is from last meeting. The one open question we haven't concluded is how should that max staleness be interpreted? There's two options we discussed. I think document in the previous meeting notes. There, I'll use one example here. Right? That's a 10 o'clock is the last refresh operation started or finished. That's it, 10 o'clock is the last refresh. At 10:45, one of the source table has a new snapshot added. Right, one of the source table changed. Now the question, that's it. The max staleness is 60 minutes. Now at 11:15, should the particular view be fresh or stale? With option one, where we say we count the time from the last refresh, then this is stale because more than 60 minutes since the last refresh. But if for option two, where we define the staleness compared to the source table, what if anything changed? In this case, it is fresh because the source table haven't changed for more than 60 minutes, right? So that's where we were we haven't concluded which option we should go. I see there's some offline discussion. Ego, I think also, Benny also left a comment in the spec PR from Yang. Ego also mentioned that it seems that option two seems to be some of the existing engine behavior also. Like I think, I don't know, maybe Benny mentioned the Trino is using option two, where if the source table hasn't changed in 60 minutes, it's fresh. I think Ego also probably going to come in. Snowflake is also kind of have similar kind of behavior. I think
actually Snowflake doesn't have max staleness. We have target log, and I think that's a little bit different concept.
Okay.
But BigQuery max staleness is implemented exactly like option two. But I think fundamentally, that's an optimization. We shouldn't mandate it. We should just say that there is a delayed view semantics. If a view could have been executed within staleness window, and the results that you would have gotten exactly the same as certain table, that's fresh table. And if your engine is smart enough to figure out that refresh from last year is actually accurate and correct and can be used, you should go for that. If your engine is really, really simple and just looks for refresh that happens in the last hour, that's fine too. I think we should define staleness in terms of delay semantics and allow engine various degrees of optimization. And some engines will do option one, and some engines will do option two, and some engines will come up with something really crazy and maybe do some option number 17.
Sounds good. I said Benny also joined. Yeah, so we can probably just open up discussion on this topic on how the staleness should be interpreted. Yeah.
Is delayed view semantics definition clear, or is it confusing? I mean, I'm just wondering. It's not 100% intuitive, maybe.
Anybody have any comment? Yeah, for me, I found it a little bit difficult to understand initially. I talked to Igor offline to understand, but I don't know if anybody else have any question on that.
Could you, if it's like, I also currently cannot entirely grasp it, if you could like, if it's possible that you like quickly explain it. I don't want to have like a huge presentation or something, but if
Sure.
you could.
So imagine you have a materialized view that basically has two parts. It has a view definition and it has store table from last refresh. And you have max talents defined as 1 hour. So really simple case, last refresh happened within 1 hour. It's fresh, it's fresh enough, nothing to see here. It's really, really simple case. The question, what happens if last refresh happened maybe 2 hours ago, but it actually captures like there were no changes for 1.5 hours. So last change happened within last 30 minutes. In that case, that refresh that happened 2 hours ago is actually equivalent, exactly equivalent to refresh that would have happened 30 minutes ago. Because nothing happened in that hour and 30 minutes.
Okay.
And for example, yes, sorry, go ahead.
No, I mean, the big point is that as long as the query engine is kind of within this max staleness window, it doesn't even need to check if anything happened, right? And in
Correct.
the other case, I think, I mean, you don't have this information that nothing happened in the meantime, right? So you kind of have to make a check even if nothing happened in between, right? So
exactly, but I think that shouldn't be mandated. That should be an optimization. Like if some engines are smart enough to do that, that check for the refresh that happens last year, but nothing happened for the year, so you can treat it as fresh. Awesome idea. Let's do it. It's actually empowering for a lot of scenarios, but I think it shouldn't be part of a spec. And the way to work around that, instead of mandating behavior, that's what check. I think we should use terminology of delayed view semantics that says if a view could have been executed within last hour and results that you would get from that view exactly the same as stored in your table, you can consider that within your staleness window. How you answer that question, there is a really trivial implementation that will do fine. And there is more advanced optimizations that you can consider to do. But again, I'm really strongly opinionated about mandating those optimizations. Right. Did that make sense, or did I mumble?
So yeah, so I totally agree that I think we shouldn't mandate too much, because I think there are many implementations out there, and I think if we mandate too much, I think, I mean, yeah, I think the goal should be to prescribe as little, but still have as much functionality working across the board as possible. And if you mean that like rephrasing the term to have better semantic meaning, then I'm all for it. Like I don't have a strong opinion on
my definition of thread, but please comment if it's unclear and confusing. I can try to expand it and make it a little bit more consumable.
Yes. So target lag. Yeah.
I just suggest a term like targeted lag.
So I feel that term is actually come from the perspective refresh. How the refresh operation should be defined. I think the max staleness kind of come from the angle of how should the staleness be defined.
Yeah, I think I can comment on that. So I have I think maybe a unique perspective here. I worked on max staleness in BigQuery, and I worked on target lag in Snowflake. And personally, my biases put in aside, I like Snowflake model better because it doesn't give hard guarantee, and it doesn't force us to jump through a lot of hoops. Getting max staleness implemented inside BigQuery and getting it exactly right and guaranteed is actually pretty hard. Because the question is, okay, fine, you figure out your max staleness, you do the optimizations, and then user queries materialized view, but it's outside of staleness windows. What do you do? Do you run synchronous refresh? Do you run partial refresh? Do you file the query? And none of those answers actually are really good. So the Snowflake decided to do target lag, which is best effort, not guarantee, but we'll kind of do our best. It may or may not happen. I think those are very different models. I prefer target lag, but I understand in previous meetings the team conversed on max staleness, so I'm not sure we have time to reverse that decision. Or
Then
So one of the complications here, obviously, as opposed to like working within kind of more of a closed engine, is we can't like over specify exactly how everything needs to work. Like I think providing something like max staleness is an intent by the author of the materialized view to say, I believe that the data should be good through some amount of time, right? And then the issue is that not all engines are necessarily going to be able to refresh that data, right? It isn't expected that all consumers can also refresh. So you can't necessarily say, hey, we'll just like go synchronously refresh and get the latest data. It may just be that if max staleness is violated, you have to fail, right? It could also be engine dependent, right? Like we can't force engine behavior to a certain extent. So this also came up with the like, hey, when you have nested materialized views, what does it mean for staleness all the way down? And right now the industry is kind of like, well, you get one level of best effort and everything beyond that, we won't even calculate for you. So implementations could take that a step further and say, hey, no, we'll calculate it all the way down for you to make sure that like everything is up to date. And you know the guarantees are a little bit different, determined depending on whether it's an analytic system versus an operational kind of like database. But I think max staleness is an intent-based thing by the author, as opposed to saying like, hey, well, you can kind of do anything. And target lag would then mean by some consumer, well, I don't know what my bounds are. If I have a target lag and it's like I'm well beyond the target lag, well, what does well beyond mean? So I that's kind of how I perceive it as max staleness is an intent-based thing. And then clients can either fail or refresh depending on what they can actually do with that materialized view. Does that make sense?
yeah, I think Igor.
Oh, Igor, sorry, you're muted.
I think yeah, you draw the distinction between two, and I think I followed you. But it sounds like you were arguing for one versus the other, and I almost heard it like you're saying, hey, let's do target lag. It's a little bit more flexible. Did I get this right? Or
No, it's actually max staleness, because like target lag, it doesn't actually mean anything across like all these systems, right? If like I don't know like what is good or bad about target lag, and like there's no hard boundary there. So anybody could say, well, target lag was 5 minutes. I'm reading at 10 minutes. I'm going to say that's good because it's better for me to consume the data than fail because it's too stale.
target lag is basically kind of optimization hint to the engine. It's saying, here is a join order. If you think it makes sense, go for it. If not, whatever, right? Yeah.
Yeah, I think the question, if we pass this target lag, what should the consumer do? What should the behave of the consumer? I think kind of max down is kind of clarify that expectation. Hey, if you're beyond that, it's stale. You should not use invalid material view or invalid materialization kind of.
Maybe we should look at angle like, there's a two type of the update mechanism for the materialized view. One is that, the batch update. Basically, you just calculate, let's say that staleness is the 1 hour. Every 1 hour, you just calculate and put that, which you don't have any knowledge about that. Is there any data insert or not? And the another approach is that incremental update. And for incremental update, of course, you know that when did you update the materialized view, or which data is updated on the source table kind of things. We can describe this optimization as a description on the field. Doesn't matter which field name we are picking. We can say that, hey, if you are going to do the update, if you want to optimize this field, you can do the incremental update, and the engine can decide based on the incremental update, is it going to be fresh or not?
I didn't quite follow that. And just to give an example, maybe specific example to kind of clarify the scenario. For example, in BigQuery, max staleness can be applied to both incremental and non-incremental materialized views. And they basically behave the same modular, refresh cost.
And what's the behavior then? Like if you're within the staleness then it will just return whatever results it had already pre-computed. If you're outside of it, it automatically triggers a refresh and it returns current results, right?
It's actually a little bit trickier than that, because it triggers partial refresh based on the query around Materialized View. So if there's a pruning, it kind of nicely works. And also in BigQuery, the kind of interesting decision there was to jump not to the current time, but to the end of a staleness window. So if customer continues to query that, there is no weird jump back and forth because suddenly refresh finished and you got fresh data and then refresh finished from an hour ago and you got data going back. So, but basically, yes, you do the query time catch up.
So I think that comes down though to implementation. I think that would be perfectly fair to implement, right, in this model, because as long as the engine is returning data within the staleness window, how it calculates or refreshes behind the scenes is fine. But for a client that doesn't know how to refresh, right, can only consume within the staleness window, it only has two options, and that is return results within the staleness window or fail and tell the client, you need to go and refresh this by something that can actually refresh it, right?
Right. I think that's kind of a downside of max staleness. We're forcing client or somebody to make a failed decision. That's makes it uneasy.
That's, you know, the challenge with the target lag though is then there is no boundary, right?
It's a hint.
It's a hint. It doesn't need to be observed, and then like the squishiness around like, well, if you're not going to observe it strictly, how much leniency do I have in that window is completely undefined. And once we define it, we have a max staleness.
Right. I agree with you. So let's say we go with max staleness. I don't have strong arguments against it. How do you think we should define the engine behavior when somebody queries Materialized View? It's outside of staleness window. Should we mandate refresh or failure? What do you think? Or should we say nothing? Just figure it out.
I think that either refresh or failure are both options. Refresh if you can refresh, but we also want to make sure that like clients. So the scenario that I like to think about is if I'm just using Python with pandas, right? I won't be able to refresh the state of that table, but as long as like something's keeping it generally refreshed, like I can consume from it. And if I have to then go to BigQuery or Snowflake to poke it to refresh it because like I'm just outside of it and it hasn't been refreshed recently, that's something I can still do from like a, you know, a DB API kind of situation or something like that, but I can still consume it via my Python client, right?
Then you would be okay getting a failure saying, hey, exception, stale data, please refresh, handle exception, refresh, and then handle it on client if engine decided not to implement online catch up.
Yeah, due to the nature of like the interoperability aspect of this, like you are going to have clients that do not know how to refresh.
Right.
Or can't execute the SQL statement because it's a different syntax or uses, you know, functions that it doesn't have access to.
Yeah, that sounds fair. I think mandating online refresh would be really high bar for engines to implement.
So yeah, I think from spec we just say it's a stale. Whether the client will do a inline refresh or we just fail, that's kind of up to the client to decide. But I did it from the storage, we just kind of tell you it's stale.
Right. When we say client, we mean query engine. I'm still learning.
Query engine or that.
Got it. Thank you.
Yeah. The consumer client. Yeah. Yeah. The new.
What was the, you know, what will be the then reference implementation behavior?
The reference implementation behavior? So I would think possibly, and this is just hypothetical, like if it was a materialized view written using, let's say, Spark SQL, you know, so the actual view definition is Spark SQL, and you're executing within Spark, and it has access to, you know, all the UDFs or whatever defined in the SQL, and it can actually execute the refresh, then you may do kind of like what Igor was mentioning, like, hey, eager refresh, because you have all the capability to do that. Why not return the result, right? If it were something else, let's say a Spark defined view and you're running in Trino, I don't know what that behavior would be.
That's why I asked that. You know, are we going to provide this functionality?
In this case, Trino should also have a SQL dialog in the view definition, because otherwise Trino won't be able to kind of query it.
Okay, so if we flip that and say it was a Trino-defined view, Spark will still try to respect that. And so we would probably still try to eagerly refresh and execute the query. If it can execute the query, because it'll try to use either Trino or Spark dialect. And if it picks up the Trino dialect and says, hey, I can run this query, it would be able to refresh. If it couldn't run the query, I would expect it to say, hey, we're outside of the max staleness, and I could not execute the refresh SQL. Refresh failed, unable to, whatever the SQL error is or something like that. So we definitely get into some weird scenarios here where it's like, you have an engine, it may or may not be able to execute the SQL, it may or may not understand the dialect, and we just have to deal with those failure scenarios because we can't mandate that everybody parse the same SQL and be able to execute a refresh.
Yes.
Do you think we'll have a lot of unhappy customers who say, hey, I've got this Materialized View, it's stale, I'm trying to read it, my refresh doesn't work, broken, whatever, just get me my damn data?
I doubt it, actually, because most of the time within companies, they have like one engine that they use to do their refreshing, and they'll schedule it. And then, the consumers themselves will either be using that engine where they'll get the eager refresh, or they just rely on whatever's available. And if they're outside of the staleness window, they'll have to trigger the refresh. And maybe you need a somewhat longer, max staleness. Who knows?
Yeah.
I think the targeted lag is more kind of towards the engine implementation or how it kind of orchestrates these refreshes, because it's kind of specific. Okay, how am I going to look that the data is up to date? And I think you could still, for each individual engine, you could still have an engine property somewhere maybe, or similar to, I don't know, do you set the target lag for Snowflake now, that you would have some configuration parameter where you do set the targeted lag, and then it's kind of up for the Snowflake engine to ensure that. And at the same time, you would just set the max staleness to a very high value, or maybe set it to, I'm not sure if we, or null or something like that. So if you want to be sure that, or if you want to use targeted lag, you could specify it on the configuration on your engine side. Just set the max staleness very high so that your customers don't run into this problem that your materialized views are constantly stale. And you could still realize this, but in this way, it wouldn't be part of the spec, as is kind of very engine dependent how these refreshes are being triggered and executed.
So are you saying, and I think I understand what you're saying, which is basically if you were doing an hourly refresh, you set your max staleness at 2 hours to accommodate for, hey, is it running a little bit late or something like that? But we also don't necessarily want people running on data that's 4 hours behind. So you still have a boundary, right, which is the max staleness, but you can this is more just operational constraints for people. Hey, how do you want to set up your data platform with materialized views? I think the target lag accommodates that in the sense that hey, if you've got it scheduled to run hourly, it'll try and keep you within that target lag. But if it goes over a little bit, things aren't going to fail, but there's no kind of end to that boundary condition, right? So if things are running really slow, you could be 3 hours behind, you could be 6 hours behind. Whereas max staleness, you could kind of put a boundary, and then it's just an operational thing for whoever is setting up the materialized views. Is that what you're saying, Jan?
Yeah, I think so, yeah.
So one interesting, I think for the, let's say, max staleness with some config, let's say 1 hour, typically you have one engine doing the maintenance, right, to refresh it. Let's say another scenario where the max staleness is 0, means I always want the strict fresh data. In this case, if you have multiple different engines, they try to refresh the table at the same time, that typically do inline refresh during the query time. That can be kind of a little bit weird, because let's say if you just have one engine, this engine may use some log to prevent this concurrent refresh. But if a different engine, this kind of concurrent refresh can be a problem. Do we need to get anything to say, hey, this view should only refresh by one specific engine? Do we need this kind of a concept, or that's too much?
It's too much, right? Basically, it's table, and both of the engines try to do the commit for the update to that materialized view?
If the single engine scenario typically uses some synchronization to kind of prevent this kind of refresh because it's kind of wasteful. Because if they have those, if they have strict freshness requirement, they do the inline refresh during query time. They typically do some coordination with, let's say if you have 10 concurrent queries, you're not going to have all the 10 concurrent to do the refresh. They typically do some coordination to prevent that.
Just to give small counterexample to that, the way BigQuery works, the inline refresh is in the context of the query. It doesn't mutate materialized view.
Okay.
With the hope that query puts a filter, there is a pruning, and it's actually like we're trying to get data to customers as fast as possible online. So there are, strictly speaking, I think 3 possible implementations. One is fail the query, inline refresh materialized view, inline catch up without mutating materialized view. I think maybe we should spell out all 3 options and kind of explain constraints around that.
That makes sense.
And in context of the BigQuery use materialized view as an optimization for the query also too. Like when you have a refreshed materialized view, it may use that refreshed materialized view data to retrieve the real query.
You're talking about query rewrite, like if part of your query looks like view, correct, and it actually does catch up in that scenario as well. It will say, "Hey, I got materialized view. It's 10 minutes off, but actually I can catch up to now," and it will do that as well. Yep.
Danny?
Oh yeah, I was going to say. I mean, yeah, regarding your question, Stephen. I mean, I feel like with the spec, like we're going to be in very like producer consumer scenarios, right? Where so I don't really see like multiple consumers like fighting to refresh a view and running into concurrency problems. I feel like you're going to have one engine that's going to be good at like producing the materialized views, and another almost like dumb consumer who's just like using them, right? And so things like max staleness are really there for operational purposes, right? It's like don't use this view if for whatever reason it's more than a day stale, right? So yeah, my feeling is that you're not going to have like concurrent like consumers trying to refresh.
Well, but I think I'm talking about where, let's say if the max staleness config is 0, means I always want fresh data. And if the engine support inline refresh with mutating of the storage table to cache the result, that's where we can get the concurrent refresh and competing for the update the storage table.
Then I feel like you might be in very like single engine scenarios, right? Where like producing and consuming engines are the same, right? And then they may have some, engine specific, locking mechanism.
Correct. If it's a single engine, yes, they may have some lock element to the coordinate. But what I'm thinking, let's say both Spark and Trino, they can do inline refresh and update of storage table.
I mean, so Stephen, that really just gets back to like the backing system that's doing those refreshes needs to have proper guarantees about like multi-statement operations and things like that. So you aren't clobbering your own MVST. If you're going to provide like inline MV refresh, right? Your system has to be able to know how to handle that. It has little to do with like what the spec is. Like obviously somebody could implement it wrong or poorly, but I don't think that that's something that we need to like spell out in the spec. Like we want to be as permissive as possible with implementations and optimize for the interoperability side of this, because there's possibly many different implementations that people want to have, but they do need consistent internal implementations, right?
Yeah, I think
right. Yeah, so like if you do the you can get the latest data, but it doesn't inline refresh the MV. Like obviously you can have as many consumers as you want. You're just paying more for the additional compute, and that's fine. But if you're gonna actually allow for refresh inline, you got to deconflict that too. Like,
Igor?
I just had one comment on Dennis' statement saying, hey, we'll have engines that produce data and complex and refreshes, blah, 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 and then we'll have simple clients. I think we're actually converging on clients that needs to be at least able to fail query for a set of max stainless. So not really simple. There is some complexity in clients that we are going to mandate here. I think that's an important point to make.
Yeah, and I would just say, like, when we come down to like specifying this, like when we get to the actual, must, should, shall kind of statements, I would say that the max statement, the max staleness is not a must, it's a should. Because I can also see clients saying, like, look, I'm overwriting this because, like, I'm not using this for, operational purposes. I just need a copy of the data, it doesn't need to be fresh. So, like, should statement for max staleness, may for, like, things like inline refresh. So I think that there's a lot of permissiveness that we can do here without being overly strict about what we specify. Like, we wouldn't want to require that everybody can refresh if they consume. That's not necessary.
Great. All right, Jan?
Yeah, I actually found the point of Stephen really, so I think even though we probably oftentimes have these producer-consumer setup, I think it's still important, like, what semantics do we prescribe with the spec? And I think it's very important point by Stephen. And thinking about it, I think I think it would make sense to do something similar to BigQuery, where in a query where you query the materialized view, inside the query you update it somehow, but you don't update the materialized view, because I think in that case you would run into frequent problems. But yeah,
that's what
I think it would make sense to prescribe it. Or
I think that's what Igor said. You can do a inline refresh, but you don't mutate the table. That would be fine. You just have some repeated computation, but they're not going to get. That can be safe cross engines. Whatever you can do, it's local kind of recomputation.
Right. I mean, the question is, should we write something about this in the spec or not? No. Okay.
No, I think I really like Daniel's proposal. We're going to say should respect max stainless and may handle it in 3 different ways: failure, online catch up, online update. Something like, if I understood Daniel's proposal a bit.
Yeah, I'm questioning, like, do we need to spell out what the options are? We may want to provide that context, but like, any may is just kind of like, well, you can do any of these things.
Consider. Yeah.
And I wouldn't even say that that's the may would be like exclusive. Like, you could do other things beyond that even, right? As long as you're returning correct results to the client that are within the staleness window, that's perfectly fine. However you want to do that.
Yeah, but I definitely agree with the principle would be permissive, right? As a spec, I think I definitely agree with that principle.
We got some hands here.
Yeah, so I want to circle back the statement around the filling the query, or the client filling the query if the materialized view is beyond the max staleness. So I think it's kind of like too strict for the client side. Like, for example, you can have a scenario where you have one materialized view read from another materialized view, and the source materialized view is kind of like, for example, 1 minute as a maximum staleness, but your second layer is kind of like 1 hour. You can definitely have a situation where the base one already outside of the maximum staleness, but the second one still, like, you are able to produce a result, right? So filling the query is kind of like too strict in this case.
So this gets to one of the areas that I don't love, but we covered, like, in I think the last meeting or the meeting before, which is the industry state for materialized views is you only get like 1 level of staleness guarantee. So if you have a materialized view that is referencing another materialized view, then, like, that second one will just be read at whatever state it's at.
Yeah, I think in the kind of view spec, like in Yang's PR, the refresh state we don't check beyond the we don't check the recursively. But if the engine want to define very strict, want to do recursively, can do it. But from the spec or from the metadata, we don't provide that information.
Okay, and like, So like, can we leave this option to the either client side or engine side to say like whether I want to file the query regarding to the max stillness? That's gonna be more reasonable.
Yes, that's the consensus from our part 2 discussion before. Yes,
Okay.
that's the consensus.
And I have another comment to Jan's proposal. Like you can have the max stillness on the view definition, and the engine can have a target lag or something like for the engine option. So like I feel like this is kind of like overlap with each other, and it's gonna be simpler if we just have the max stillness on the view metadata, and the engine can use this as a hint. Like your nature, yeah.
Use other properties, like, right? So if your engine wants to have a target lag, like you could have a property. It's just not part of the spec, right? The spec would only just define max staleness.
Yeah,
and
I think
the other thing is like a tuning option, basically within an engine implementation.
Yeah,
I also
so-
think engine doesn't even need to store it. For example, if an engine look at the max staleness to be 1 hour, it can just put the scheduler, that's airflow. Hey, I will schedule refresh every 30 minutes. It may not even need to store in the ICE table even.
So, well, this like target lag stuff can be specified by the customer, or it's kind of like a purely internal configuration for engine itself.
I would think that we don't want to specify it, right? And that
Okay.
leaves it up to whoever is implementing the refresh, engine side of things to figure out like, hey, what works best for them? Because
Yeah.
like, if you have something like just like Spark OSS, like, well, that doesn't necessarily mean anything because there's no paired like scheduler or anything like that. So it doesn't have any intuition about how to interpret target lag, right? So we wouldn't want to specify it, but there's no reason why there wouldn't be different implementations. Maybe they have target lag. Maybe they have a refresh, like period or something like that, where it's hard. It's not like squishy, like a target lag. There's lots of different implementations. We don't want to be overly prescriptive.
Yeah, I think that totally makes sense. Like, I want to avoid a situation where the Materialized View author need to think about what's going to be the max stillness for my view, and I also think about if I plug into Spark, for example, what should I specify the target lag? It's going to be super complicated for the end customer.
Yeah.
Yeah, that's my
All right, Penny.
Couple of things. I mean, like if you think of these properties that we're putting on the view as like, producer, hints to the consumer, right? You could argue that like target lag is something that the producer is saying, hey, this is a setting the consumer should use, right? So I'm just arguing the other way for this, right? I mean, it is getting, I feel like it's almost getting a gray area, right? Now the other comment was, okay, so if max staleness is a, should, property that the consumer should try to implement, right? I think we may have to be more clear about in what scenarios does max staleness apply? So like if like the view definition contains all iceberg tables, right? Then and if you look at all the nested views, they're all iceberg, right? And for sure, you could say, well, max staleness is kicks in after like data has actually changed, right? Not like when you built the materialization. But like fact of the matter is that there's going to be view sequels with like non-iceberg tables, right? Maybe like relational database tables. So in those cases, you don't know when data has actually changed, right? And so you could only really base your max staleness on when you built that materialization, right? So I feel like that distinction, should be called out in the specification, right?
Yeah, that's actually one question I list in my agenda. Do we want to support non-iceberg source table system view? And even let's say we want to support, I still think there is a solution to the question Benny you asked. For example, if we cannot figure out the source table state, we just assume this change. Then that go back to the refresh. If it haven't been refreshed in the time, we can kind of fall back to that behavior. Anyway, I let Ego talk. Yeah. You muted. You.
Delayed view semantics addresses that. It's basically saying, here's the definition of a view. If you can make a guarantee that data would have been retrieved during this time would be equivalent, go for it. If your data is coming from somewhere else where you don't have timeline, you obviously cannot make that claim. You cannot apply optimizations. You have to rely on the last refresh. I mean, we can document it, but it's just an implication of careful delayed view semantics definition.
Yeah, I think we need to think through like how we want to define the staleness aspect of things, because like calculating staleness is a little squishy too, because you could look at something very primitive like, hey, has the the table metadata changed, right? And that could be schema change but no data change or something like that. Maybe it affects the query, maybe it doesn't. Like a very coarse grain check would be it mutated in some way, and like I know when it mutated, and if I'm outside of that window, then my max staleness is violated. A more intelligent engine may be able to say, well, look, I see that the table changed, but it was a rewrite operation, which means the data did not change.
Mm-hmm.
And I can still let the query go through. So you may end up with different calculations by different clients that result in slightly different behavior. I'm not sure if we want to address for that, because like you could get really complicated. Like you could say, hey, the filter for the view definition excludes the data that changed upstream of it. It's still valid. But only like a really intelligent engine could make that determination, whereas like a Python client would not be able to do that. So do we specify that clearly, or do we just kind of leave that to, hey, you need to validate that whatever you're returning is within the correct data representation within the staleness window? I kind of feel like we need to lean towards the more generic side of that statement than anything.
Right.
Yeah.
So what do we document though in the spec, right? If someone says, okay, so what does staleness mean? Right, we have to have something there. Well, like what would you recommend?
Let me try to run through delayed view semantics. If you were execute that view during your staleness window, and there exists at least one point where results of that view match whatever you have stored, that view is considered within staleness.
Yeah, I think that definition is kind of pretty generic. It doesn't.
And
specify-
some engines can say if schema changed, I not fresh, and some agents say, no, you just add a column, nobody queries it, or rows, nobody queries it. I'm really smart enough, I know what's going on here. I have a license to do any kind of optimizations I can imagine.
Yep, I like that.
Yeah, I
It
think that
still
one
will
thing-
result in slightly different, calculations, but as long as they all converge on, you won't get data that does not abide by the staleness requirement. You just may fail too early in some cases, and you may get more out of more intelligent engines.
Yeah, we can work on the wording too, because I then imagine people when they look at this sentence, they may find, hey, what does it really mean?
We can clarify, like it doesn't have to be just that sentence, like we can add context to it. So
That's why when I first read the sentence that equal shared in the email, I have a hard time to really understand what that means. But I like the kind of generic aspect of that definition. Yeah.
Definitely we should be stay in the generic, in my view, because if we start giving the more details, then we start dictating to how it's going to be implemented. This is also an issue for the engines itself. And I just ask on the chat also to for nested staleness refresh consensus, the whatever we call that, currently we know that we just only have one guarantee, like the one level guarantee. Should we capture that information on the spec? Then should we say that the spec is expecting just one level, the freshness, but it depends on the engine. It can do the cascading freshness or just one level. This is the minimum that we are expecting.
I think Yang already updated the spec PR to say, hey, we don't go beyond the source material view.
Okay, maybe I missed that. Did you update it?
I think that's what discussed in the first meeting.
I updated it, but I'm not entirely sure what I wrote.
But yeah, we So I think the consensus that we're not the refresh state only just going to have the source material view storage tables. There's a snapshot ID in there, for example. We are not going in the refresh state. We are not going to have an entity for the transitive storage transitive table from the source material view. We're not capture that in the refresh state. But the engine can do that additional evaluation if you choose to, but in the reverse state, we're not going to have those information.
Oh, makes sense.
Yeah, I think the same principles that we talked about before, I think we should leave it kind of entirely to the engine. And since, I mean, it's not convenient for the query engine to fetch all research, it would be more convenient for the engine if all the states were inside the refresh state, but it still has all the stuff to query the catalog multiple times and eventually determine the freshness of every source materialized view and even nested ones, right? So it totally depends on the engine.
Alan?
No, not me. I am done.
Oh, okay.
I was just going to add that, like, while we want to make sure that the client has enough information to calculate staleness itself, and to cascade if it needs to, and it should, like, it's loading all of this information. When we get to the point of like updating the REST specification, we can also include something that is a catalog calculated side staleness, right? So when a client loads the table, it would already have basically the calculation done for it, because it's very possible that the catalog can do that much faster and avoid many hops from the client to go and interrogate every single table. And the catalog can say, hey, I calculated staleness for you, you're good through some time, or something like that. So I think that there's a lot that we can do to improve the calculation side of things. Jan?
I'm a bit burned by the staleness or discussion that we had like a long time ago with Walla, where what do you do if catalog identifiers are different? What do you like? What if the same catalog is registered in this query engine like this query engine like this? And I think if you wanted to have some catalog calls, you would need to have some identifier dependent endpoint. So I'm a bit scared of that, to not start this whole debate again. I think at the point we kind of agreed that we just leave it to the SQL and you have to parse it every time. So it's dependent on your setup, and it makes sure that every setup is correct and it works correctly. And issue here is always kind of the inter-engine interoperability. And I'm just saying that
we don't need to solve that here. I understand your concern based on those discussions. I'm just saying that we absolutely, as part of the spec, we definitely want to define like how clients calculate staleness, right? Or how they can, what information is available, probably should indicate how they should calculate staleness. Of course, engines are free to optimize how they do that, right? I'm not terribly concerned. I think that that's a separate issue than the catalog issue. So we can deal that when we get to the REST catalog. I don't think anything we do here is going to change that. So.
Yeah, I was part of that discussion, and I'm starting to see what Daniel is saying. I mean, like I'm because now I really believe that you're going to have like smart producers and dumb consumers, because it's really hard for the consumer to parse the SQL, to have the, to be able to expand the same SQL the same way as that consumer did, as the producer did, right? It's just, you have different dialect problems and UDFs and whatnot, right? So, and also metadata calls are extremely, network expensive. So if the catalog could tell you that the view was was up to date, that's great, right? So I think it's starting to be a very good use case.
We have 6 minutes. Sorry, go ahead, Yeah, go
just
ahead.
very quick. So you were thinking about an endpoint for a materialized view where you query the catalog and it returns as a result, yes, you are fresh, or you know you're stale, or something like that.
Something like that, right? Like we can worry about that when we do the REST catalog kind of side of things, because we have to, like, once we define the materialized view spec and get that all codified, then we need to figure out, well, what does it mean for updating the REST spec? And that, you know, we have to add a few more fields to the view definition for materialized views. Whether it is a materialized view, and we can talk about, like, hey, do we provide hints or signals about freshness through that same mechanism?
Right.
Yeah, it'll be optimization, because it can also catalog come out, don't do anything, just let the engine decide. It's also possible. Igor. Yeah.
All of that optimization stay in the may, at most, should category, right?
All right, so we have 5 minutes left. I think for the Bennett's question about supporting that's a non-iceberg source table view, do we have any like comments on that?
That's really hard, right? Because one, like, we don't even know what to store in the table state for those tables.
Well, the behavior could just fall back. If you don't know the state, you just treat it as stale.
But I don't know how that works, right? Because if it's automatically treated as stale, no consumer could consume from it without reading the live data.
No, if you have, let's say, max staleness with 6 minutes, then you can still consume data.
Or just consume it within the staleness window.
Correct. Yeah.
So there are some implementations out there of things like this. You know, if you have in some systems like multi-statement transactions, and there are things that can't work with transactions, you can't run the transaction, right? And the parallel here would be, if you can't determine the state of the table, you can't include it in a materialized view. So that's the hard condition. I think that it's hard to generically determine what the state is, so I think it would be forced to be max staleness based on whenever it ran, like Stephen was suggesting.
Which I think is reasonable behavior, right? If that you have max staleness 1 hour, yeah, as long as I'm within an hour of last refresh, it's still usable. If I know the source stable state, I can do more accurate calculation. I will do that.
How do we, for a client that needs to potentially calculate staleness, how does it know that there's something that needs a staleness calculation? Like it couldn't, like, no client could then look at the storage table information. Like, how do we define that there was something in this view that we couldn't track state on?
So, for example, if the source table, it will be, if the iceberg table, if source table iceberg, that would be snapshot ID. If there's no such information, just we don't know the source table state.
But what are we referencing though? Like, right now, I believe the only things we reference is like the ID to the snapshot, and now we're saying, well, it's actually going to be something else.
That's another problem. Yes, we're not calendar spec. We're saying we use UUID, table UUID in the reverse state.
Yeah, and we don't even necessarily have an identifier or something like that we can use.
Correct. Yeah, that's
so it's, I think that's so one option would be you only use the state of the iceberg tables, right? Any other state is outside of the materialized view guarantees, right? So you only populate you would populate the same information for tables that have iceberg data and ones that don't. The only case that would be weird is you create a materialized view with no iceberg tables in it, right?
We have Pala. Pala, go ahead.
I believe, this spec is very long time waiting spec, and we can always reduce to increase the scope for this spec with follow-up spec updates. I believe we need to reduce the scope just iceberg specific. When the Daniels and Ryan designed the tables, they didn't think about the other engines table and the iceberg table together. That could be the case, like, hey, how we can do those kind of things to use the other engines. Let's stick with the iceberg scope. I definitely agree. I like the idea, by the way. Then we can use the materialized view as a refreshment mechanism for the ETL jobs, but let's stick with the, at least first version of the Iceberg Materialized View spec in the Iceberg scope.
I agree.
Yeah, makes sense.
Okay.
Yeah.
Don't further complicate it, and we can still use other tables. We're just saying that it's not part of the state calculation, right? You get what you get.
And I wanted to say, I want to say exactly what Talat said. That would be great. I think to reduce the scope for now, maybe we can like think about if there's like some way where we can kind of leave like to simplify these future additions. If there's like some way that we make it opaque at some point, or I don't know. But actually, I agree. I think we should kind of get this first version in and then maybe improve from there.
I also agree. Yeah. Let's keep the first version out first.
Yeah,
All
I
right.
mean, even the consuming engine could do its own thing, right? Like it could still parse the SQLs and see that there's non-iceberg identifiers in there, right?
That's a problem because the request does not use UID. For some non-specific that not even UID. We
Yeah.
don't know how to keep putting.
Yeah, but it still has to parse. It could still be on consumption. It could still parse the SQLs and see, hey, you got tables in here that are not represented in the refresh state, right? So you're in this like other scenario where you got data you can't track.
All right. So we're out of time. Yeah. Thank you, everyone. I will send over the meeting summary today.
Great, thank you.
Thank you.
Thank you. Bye.